Okay, so you're welcome to this class, and in this class I'm going to talk about what matter is, what elements are, what atoms, molecules, and ions, and so on. You know, this topic or this lecture series of lectures is a basis to understanding how to name compounds, how to balance equations, more concepts, and so on. You know, most students have issue with this topic, and you know, if you have the basis, understanding those ones will be very simple. Okay, so first of all, matter. We all know that matter is anything that has weight and occupies space. You know, we have matter to be solid, liquid, gas, and there is a new one called plasma, which is not our main focus for today. We are just going to look at solid, liquid, and then gas. So now when you take every solid, every liquid, and every gas, they are made up of particles. Now, every solid, for example, when you take chalk, and this chalk is broken into pieces, that tiny piece is made up of elements, and there are about 112 or so elements or so. The same with liquid, the same with gas also. So let's give an example of solid. Let's say a stick. Liquid, let's just take water. For the gas, let's just take, let's say, hydrogen. Now with this stick, you can break the stick down into pieces. To get to the little, you have an element, whether maybe carbon or any other element, forming this solid. Water, we have hydrogen and oxygen. With hydrogen, we have atoms of hydrogen coming together to form the hydrogen itself. So in our next thing we are going to look at, what atoms are, for you to get what they are. One thing I would say is that elements are made up of elements are made up of the same type of atoms. Yes, elements are made up of the same type of atoms. So you have matter, the three states of matter: solid, liquid, and then gas. So the next thing we are going to look at is the atom, which is a particle of matter, a particle of a stick, a particle of water, which is liquid, a particle of hydrogen, which is gas. Okay, now, so we are looking at particles of matter now. We just looked at what matter and what elements are. We said that elements form part of the matter, but you know, elements are made up of smaller kinds of atoms. So now these are what we are going to look at now is particles of matter. And these particles of matter, we have atoms, molecules, and then ions. We have atoms, molecules, and ions. You know, when we say an atom, to break it to the simplest for you, I'll say that atoms are the basic units of matter. Atoms are the basic units of matter. And these atoms, the same kind of atoms come together. That's when you get an element. And these elements come together to form the states of matter we know. So I'm saying that basic unit of matter. And a lot of these atoms also come together to form the element, as I said. Now, looking at atoms, let's look at the structure of an atom. Okay, so we have the neutron and the proton found in the nucleus, and you have a shell on which you have electrons which orbit. Orbit simply means they go round. Okay, so this is the structure of an atom. We have electron, nucleus, then the P in it stands for the proton, then the small n in it stands for the neutron. This is the structure of an atom which was proposed. Now, these electron, proton, neutron, they are called the subatomic particles. So the electron, the proton, and the neutron, they are called the subatomic particles. The nucleus houses the neutron and the proton. Now, when it comes to the charge of an electron is negative. It is negatively charged. Electron, negatively charged, and a proton is positively charged. And then the neutron, as the name implies, neutron, so neutral, is negatively charged. Sorry, it has no charge, so 0. Electron is negatively charged. So, continuing, we'll look at their masses as well. The mass of an electron is 1 atomic mass unit. Proton, okay, so I think I need to make a correction here. Electron actually does not have a mass. Electron has a mass which is negligible. Sorry about that. Proton has a mass of 1 atomic mass unit, and neutron also has a mass of 1 atomic mass unit. So going over again, this is the structure of an atom, and I said the subatomic particles are the electron, the neutron, and the proton. And I'm saying the nucleus houses the neutron and the proton. And we spoke about the charges. Electron is negatively charged, proton is positively charged, neutron, neutral, 0 charge, and then the masses. Atom has a mass, which is, electron has a mass which is negligible, proton has 1 atomic mass unit, neutron 1 atomic mass unit. There's a question students are mostly asked: why are atoms electrically neutral? And over here we can see the structure of helium. Helium is the second element and among the first 20 elements. And looking at helium has a neutral charge. Now I'm going to explain why. When we looked at the structure of an atom, you remember we said that atoms have a positive charge and a negative charge. And the positive charge is as a result of the proton, and the negative charge is as a result of the electron. So we are being asked why atoms are electrically neutral. So helium has 2 protons. That is the second element among the first 20 elements, as well as 2 electrons. Now, anytime you have a neutral atom without a charge, when I say a charge, for example, when you have something like hydrogen written here, and you have plus down here, plus over here, this is a charge. Helium over here does not have a charge. It's written at the top right corner. Helium here does not have a charge, so the charge is 0. The reason is because, I said it has 2 protons, 2 electrons. We know protons are positively charged, electrons are negatively charged. So since you have 2 positive charges and 2 negative charges, what's going to happen is that they are going to cancel out. So that's why helium over here is neutrally charged, or has no charge. It's neutral. Now I want us to look at something. We'll look at ions into details, but I want us to look at how to determine the number of protons and then electrons of both charged and neutral atoms. Let me write another example. We have calcium. another calcium here, but this calcium has a charge of 2 plus. Now we said atoms have both positive and negative charges. This calcium over here is neutrally charged. It's neutral, not neutrally charged, it's neutral because it doesn't have a charge. And among the first 20 elements, calcium is known to be the 20th element, so 20 protons as well as 20 electrons. Yes, so 20 positive charges, 20 negative charges, they cancel out, you have 0. Now you have calcium ion here. Now, looking at this 2 plus, it means that you have an overdose of the number of protons or the number of positive charges. And one thing you should take note in this lecture is that proton number does not change. Now we are going to mention proton number in other topics, other subtopics. So let me write it here. The proton number of an atom. So the proton number is constant. It never changes. So if there is any change, the change should affect the number of electrons or the number of neutrons. Proton number does not change. Proton number is always the same for a particular element. So over here, we have 2 plus. So this is telling us that there's an overdose of the positive charges. So we are going to have 20 protons, since 20 protons do not change. So how many electrons does this calcium ion have lesser than the number of protons? It's definitely 18 electrons, so that you will have 2 extra positive charges to be carried over here. Now, another thing also is that you could have an element which also has a negative charge. So let's say you have fluorine, negatively charged. Fluorine is the 9th element, so 9 protons, as I said. 9 protons. So 9 protons. Since you can see an extra charge here and number of protons does not change, it means that the number of electrons have increased by 1. So you will have 10 electrons. Now, as I said, number of protons does not change, but number of electrons can change. Now, to help you remember this thing very well, this phenomena about the charges and then the number of electrons. You know, in mathematics, anytime you see plus, it means that you are adding something, you are increasing. But over here, when you see plus, it's the opposite for the number of electrons. When you see plus, it means you are losing a number of electrons. And when you see minus, it's the opposite as well. And when you see minus here, it means you are adding more to the electrons. So let's say if you have an element like oxygen 2 minus oxygen ion, what are you going to have? Oxygen is known to be the 8th element, so 8 protons. So since there are 2 extra charges here, it means that you are adding 2 extra electrons to the number of electrons. You are going to have 10 electrons. I believe this is very clear. You will go now. Any element which has a charge is known as an ion. We'll look at what ions are into details in the subsequent lectures. So over here we are going to look at what molecules are. Now, what are molecules? We've spoken about atoms. We are saying that atoms are the basic unit of matter, and we said that when you have the same kind of atoms together, they are called elements. Now we are going to look at what molecules are. So, a group of atoms bound together, molecules. Now there are 2 types of molecules. We have homonuclear. Don't worry about the name, it's something very simple. Homonuclear and the heteronuclear molecules. If you know what homo means, it means that the same. So you can have different kind of atoms or the same kind of atoms bound together. Now when you say homo means the same. So when you have 2 oxygen atoms bound together, it's a molecule. You can also have nitrogen N2, you can also have fluorine F2, you can also have hydrogen, H2. You can also have, okay, you have oxygen, nitrogen, fluorine. You can also have chlorine also. Now when we say heteronuclear means they are not the same, they are different. So you have H2O, you have CO, you have CO2. So this is H2O is water, this is carbon monoxide, this is carbon dioxide. Oxygen molecule, nitrogen molecule, fluorine molecule, hydrogen molecule, chlorine molecule. So these are the types of molecules you have. And another thing also you need to know is that we have molecules which are diatomic. When we say diatomic, it means that you have only two atoms or two atoms of the same kind or two atoms of different kinds. So this is diatomic because atoms of the same kind. This is also diatomic because atoms of different kind. They are two. So diatomic. These are diatomic because atoms of, whether they are different or they are the same, they are two. So over here you have carbon and oxygen, hydrogen and oxygen, carbon and oxygen, diatomic. Oxygen and oxygen, nitrogen and nitrogen, fluorine and fluorine, hydrogen and hydrogen, chlorine and chlorine. Okay, so this is the last subatomic particle of matter we'll talk about. Now I said that the states of matter are solid, liquid and gas. And I mentioned also that the subatomic particles of matter are the atoms, molecules and ions. We've already spoken about atoms as well as molecules. Now let's look at ions. When you say an ion is a positively or negatively charged atom. So atom, positively charged or negatively charged. So I just wanted to make it look like that. So let's just take it this way. So positively charged atoms or negatively charged atoms. That's what an ion is. So how does an atom become positively charged or negatively charged? I think let me perfect it. We have positive charge and then negative charge. So a positively charged atom is called a cation, and a negatively charged element is called an anion. Now, to be able to remember them easily, now look at the T. You're almost writing like a plus. So when you write cation with the T, plus like that. So plus like that, positively charged. And when the anion, when you're writing your capital A, you make a cross through it, a horizontal cross through it like this. So that shows you that when you see the plus, you're dealing with a positively charged element, and when you're dealing with the minus, you're dealing with a negatively charged element. Okay, so I want us to look at some examples of elements which have charges and those which do not have charges, and determine how we'll be able to state the number of electrons and number of protons. So let me write just a few over here. So we have Mg, Mg2 plus. Then we also have Cl, Cl minus, and I'll add N, N3 minus. Then the last one I'll add Al and Al3 plus. I just want us to state the number of protons and number of electrons for each of them. So let's start with the magnesium. As I said earlier on, if it doesn't have a charge, it is neutral. We know that the number of protons magnesium has is 12 protons. Since this neutral, it also have 12 electrons, so they cancel out. Now looking at this one, you have Mg2 plus. As I said, proton number does not change. but the electron number can change. But over here we have 2 plus. The plus means it has lost. How many electrons has it lost? It has lost 2. So 10 electrons. Chlorine is the 17th element. So 17 protons. And 17 electrons since this neutral. Now you can pause the video and then try the rest. Okay, so continuing, we'll have chlorine with a minus. This minus here is -1. So you are going to have 17 protons. As I said, proton number does not change. Minus over here means that you've added 1 electron, so 18 electrons. Nitrogen has 7 protons, meaning the 7th element, then 7 electrons, since it has no charge. Then again we have nitrogen here with a 3 minus. This 3 minus means that it has gained 3 electrons. Proton number remains the same, gaining 3 electrons to have 10 electrons. Aluminium over here is a neutral aluminium with 13 protons as well as 13 electrons because it has no charge. But over here it's not the same. 13 protons same because it's not charged. Then you have 10 electrons because it is losing 3 electrons. So that is that with the subatomic particles. We are going to look at electron configuration, and I know my circles don't look so perfect, but let's try and then look at what we can do with them. Okay, so now in drawing electron configuration for elements, each shell has a particular energy, and these shells have specific names. Now when you are drawing an atom, the first one you draw is for the nucleus. The preceding ones are the ones which carry the electrons. So this first one, we call this the first shell. It's called a K shell, followed by this one, L shell, alphabetically in alphabetical order, K, L, then M shell, then N shell, K shell, L shell, M shell, N shell. So the K shell is the first shell, L is the second, M is third, and so on, N is fourth. Now you need to be able to identify the number of electrons each shell can accommodate, and to do that you will need a formula. This is a formula, 2n squared, where n is the shell number. So let me rule a line here, and then let's do a little calculation. So 2n squared, to get the number of electrons the K shell can accommodate. So K, 2n squared, 2 squared. Now what's the value for K? K is 1. So our answer is going to be 2 times 1, which is equal to 2. So K shell can pick 2 electrons. L shell, 2n squared, 2 squared, 2 times 4, 8 electrons. Now take note, you don't multiply before you square before you multiply. KLM, 2n squared, 2, 3 squared, so 2 times 9 is going to be 18, followed by the n, 2n squared, 2. So you're going to have 2 times 16, which is going to give us 32. So 32 electrons. Okay, so the K shell takes 2 electrons, the L shell takes 8 electrons, the M shell takes 18 electrons, and the N shell takes 32 electrons. Now, when you are drawing the electron configuration for the first 20 elements, there's something you have to note. It's called the octet rule. The octet rule. The octet rule states that the highest number of electrons a shell can have when you are drawing is 8. Oct means 8, except the months of the year, which 8 October is not the 8th. But when you hear octagon is 8 and so on. Others which have oct at the beginning or their prefix. Oct is 8. So we are going to look at some electron configuration for certain elements and so on. So now when you are asked in a multiple choice question the number of electrons, let's say the M shell can take, you can write 18, but when you are told to draw on the M shell, you don't draw 18 electrons on the M shell. The highest number of electrons it can take is 8. You will appreciate this better when we draw the electron configuration for elements like potassium and then calcium. So these are the drawings of some of the electron configuration for some of the elements. So we have hydrogen here, 1 electron, so that's it. So one thing you should take note of is that when you are doing electron configuration, you're actually drawing the number of electrons. So you take note of that. So beryllium, 4 electrons. You realize that the first shell takes 2 as the highest, so only 1. Here, beryllium is 4, so 1, 2, 3, 4. That's for beryllium. Then neon is 10. First shell takes 2. So phosphorus also has I think 1, 2, 3, 4, 5, 15 electrons. So you can see that the first shell took 2, the second shell took 8. Then now we expect that KLM, the M shell is supposed to follow the octet rule. Now let's look at what we have beneath. Looking down here, let's just take our attention towards this part. We have potassium here, which has 19. So it's going to be, you're going to have 19. So you're going to have the first shell to have 2. The second shell is going to have 8. Now you realize that you have 9 more remaining. Because of the octet rule, you're supposed to put 8 on the third shell and the remaining 1. So it means that after the M shell, the preceding shells also follow the octet rule. So let me just do a number configuration over here. So you have 1 over here. For beryllium you have 2, 2. For neon you have 2, 8. For phosphorus you have 2, 8, 5. So potassium. So this potassium, K. Then this calcium. Let's look at calcium as well. Calcium will also have Calcium also have 2, 8, 8, 2. So it also followed the octet rule. So this is just something simple to make you understand how electron configuration is done. And I also told you to take note of the what you have on the shells are called electrons. So let me just try to do something over here. Let's say you have H+. I'm told to draw the electron configuration for H+. Hydrogen has 1 electron on the outermost shell. So when you are drawing the electron configuration for H+, you are going to have something like this. No electron. Why? Because the electron has been lost. So you can apply the same for the rest. When you have an anion, it means you are going to add 1 more electron. I've already done the explanation to this, so I don't think I need to say much about it.